основном лекция будет на английском, а вопросы и ответы будут на обоих языках, в зависимости кому как удобно. Добро пожаловать на очередную публичную лекцию, которую организует Институт государственного управления и политики Университета Центральной Азии. И мы рады приветствовать Всемирный банк, представителей Всемирного банка, которые проводят с нами очередную лекцию. Мы очень ценим то, что банк использует нашу площадку для того, чтобы свои результаты презентовать. Если никто не возражает, я бы сразу перейду к делу, представлю тему и потом наших спикеров, и потом перейдем сразу к лекции. Значит, тема наша сегодняшняя называется, как вы видите, методы оценки бедности и потребления на районном уровне в Кыргызской Республике. Здесь важно понимать, что до сих пор бедность оценивалась на уровне больших регионов, областей или страны в целом. И вот сейчас довольно существенные новшества вводятся в методику оценки бедности для того, чтобы на более детальном уровне измерять самую бедность. Послушаем, как это происходит. Значит, нашим докладчиком является господин Уильям Seitz. Он является старшим экономистом определенной структуры Всемирного банка, наверное, нет необходимости точно вдаваться в название. И господин Seitz, он базируется в Алматы, является лидером группы, которая занимается вопросом бедности и равенства в регионе Центральной Азии. Он занимается вопросами измерения бедности, анализа рынка труда и методов проведения обследований. До того, как начать работать во Всемирном банке, он работал как исследователь в Центре по исследованию африканских экономик в университете Оксфорда. У него есть степень магистра делового администрирования из университета Денвера и докторская степень по экономике из университета Милана. Вторым нашим докладчиком является госпожа Saida Ismailakhunova. Многие ее, наверное, уже знают. Она является экономистом в местном офисе Всемирного банка. И она очень много работает тоже по вопросам бедности, равенства, укрепления национально-статистической системы и социальной защиты. Она имеет большой опыт работы в правительстве, в Министерстве финансов Кыргызской Республики, в сфере макроэкономики и прогнозирования. У нее есть кандидатская степень по экономике и мастерская степень по общественной политике из Японского университета. На этом краткую презентацию мы можем завершить. Значит, я хочу объяснить регламент. Сначала будет лекция, 40 минут, скажем. Во время лекции большая просьба, если у вас есть уточняющие, такие горящие уточняющие вопросы, поднимайте руку, задавайте, это можно будет. Если у вас более глубокие вопросы или у вас комментарии, мы очень приветствуем, но это по окончании лекции уже. Значит, потом после лекции у нас будет еще там столько же времени, более-менее 40 минут на то, чтобы подробно обсудить все, что слушатели считают нужным спросить или высказаться по поводу услышанного. Последняя большая просьба свои мобильные телефоны перевести в тихий режим, чтобы не прерывать лекцию. На этом позвольте передать слово господину Сайцу.
Если позволите, я пару слов скажу. Добрый день, уважаемые коллеги. Большое спасибо за ваше внимание и разрешите мне со своей стороны тоже поблагодарить Университет Центральной Азии и Романа Исааковича за предоставление нам площадки Университета Центральной Азии, поскольку мы достаточно частые гости, и мы очень рады, что темы, которые мы представляем, и методики, которые использует Всемирный банк, они вызывают интерес у нашего не только академического, исследовательского сообщества, у экспертов. И поскольку я работаю в офисе Всемирного банка и нахожусь в городе Бишкек, мы всегда рады ответить на ваши вопросы, даже после окончания наших открытых лекций, и держать связь между исследовательским сообществом по различным вопросам. Поэтому и на этом разрешить еще раз поблагодарить Руца и предоставить слово моему коллеге Уильяму, который, кстати, я бы хотела отметить, он имеет очень широкий опыт работы в различных странах мира, не только по Центральной Азии и Африке, как уже отмечалось, но и в странах Евросоюза. То есть он достаточно очень не только профессиональный, но и знающий человек по различным аспектам измерения благосостояния. Поэтому, если у вас есть и будут какие-то вопросы в этом направлении, тоже, пожалуйста, я думаю, это очень хорошая возможность использовать его присутствие у нас в Бишкеке. Большое спасибо.
Thank you so much for all of those kind words and the kind introduction. It's really a pleasure to be here. Thank you very much for having me. So I'd like to talk about some preliminary results that we have generated for local poverty estimates at the Rayon level. We're doing this work for all of Central Asia, for at least the countries for which we have data, which excludes Turkmenistan. But the application is at the country level, of course. This information is mostly useful for policy making, for the dialogue within a particular country. And so this is a presentation of results that we've been working on, but we're hoping to learn just as much from you in this exchange as we're hoping to share what we've found. This is still a work in progress, so if you have comments, ideas, thoughts about how we might improve on it, we'd be very glad to hear from you, either during this talk or over email afterwards. So let's get right to it. The poverty mapping or small area estimation is a solution or a partial solution to a problem. The problem arises because when we monitor welfare indicators, we commonly do that using the survey-based approach. And the reason for this is if we were to go to the entire population of a country and ask what their income is or how much their consumption was, this would be an extremely expensive endeavor. In fact, we do something like this called Census, and it's an extremely costly exercise. Usually, most countries only do it every decade or so. And the number of questions that are asked on a census questionnaire are quite limited because the more comprehensive the questionnaire becomes, the more costly it is to implement. And so we need something that doesn't require this level of cost and effort. And so the approach that's used in most countries, almost all countries, is to use sampling-based surveys. So a survey of this type would take a sample, a representative sample of the population, and using that sample would develop a rich set of statistics that are then informative for the rest of the population. So this can be a relatively small group of people. If you're only trying to get a national estimate, usually the sort of the minimum survey size would be something around 1,500 households for a country, for an estimate of, say, poverty or consumption or income. So the issue with sample sizes, though, is that when you try to disaggregate and get into more detailed analysis of subgroups within the overall population, you need to have a sufficiently large sample within each of those subgroups for it to be informative. So you quickly, after you pass, say, 1,500 households or so, you're not going to get a lot more precision at the national level. But if you want to talk about every oblast in a country, for instance, you need to have a sufficiently large sample size for each of the oblasts for that number to be representative. And this continues. So if we were to look at, look at rayons, and we wanted to have a sufficiently representative sample for rayons as well, you would need to have a sufficiently large sample in each rayon for that estimation. And this quickly becomes very costly. And so most countries will make a determination, they will balance between the cost and the precision that is required by the survey design. And it depends on what the survey is being used for. In some cases, it's sufficiently important to have a large degree of precision at the local level, and so the sample size will be designed accordingly. In other cases, a simple national average number. In other cases, a simple national average number is is all that the country is sort of looking to achieve. In which case, the overall national sample doesn't need to be as large. So, but this sort of approach, of course, comes at a cost, and the cost can be expressed as a statistical measure called sampling error. So when you have sampling error, you end up with a measure, say a consumption or poverty or income, that has a confidence interval around it. We're not sure what the exact value is. We have a point estimate that we've measured, and then we have, say, a space around that estimate. Often we would put bounds on this at 95% confidence to say that we are sure that we are 95% sure that the estimate, the true estimate, is within these two bounds, the upper and lower bound. So as the sample gets smaller, the larger this 95% confidence interval becomes, and it becomes more and more difficult to interpret the results as being informative for any particular policy discussion. So one option would be to increase the sample size, which comes at a cost. We know that you have to pay to increase the sample size. You have to find more people to enter the survey and resources for that. But there are statistical options where you can try to improve on the precision of these estimates. So this is what we're going to talk about today, is how we can improve on the statistical representativeness of data at the local level using statistical techniques. So there's there's a sort of a suite of different options around this called small area estimation. The most common one, or maybe not the most common, but probably the gold standard, you could say, is an approach called, it's often referred to by an acronym, ELL. Elbers, Landru, and Landru wrote a paper in 2003 that described this method in detail for the first time. And the idea behind this is relatively straightforward. So I'll try to explain it first, so maybe we can draw a distinction between this sort of gold standard approach and the approach that I'm going to actually apply, which is a bit different. So the ELL approach basically takes the strength of two different data sources. So in the survey, we just talked about how it has a strength that it has very rich information. It's very detailed. If it covers consumption, for instance, it can cover many questions. We have a lot of rich information about each household. The downside, of course, is the sampling error, that we don't have, that there's some imprecision in these estimates. When we go to another source of data, for instance, the most common one used is the census in a country when we're using an ELL approach. The census has no sampling error, right? It includes every person in the country when you do a census. So there's no source of error on the sample. But the drawback that I mentioned before is that it doesn't cover very many subjects, right? So in Kyrgyz Republic, as in most countries, there's no income measure in the census. There's no consumption measure for sure. That would take more than an hour for a household to complete in each case, which means the cost of doing the census, which would be enormous. And so the approach basically takes these two sources of information and borrows the strengths from each. So you take the survey and you try to develop a statistical model that predicts the value of consumption or predicts the value of income in that survey as precisely as possible. So you're trying to explain the variation of consumption or income based on what you know about a household. So if you have a certain number of children, if you have an employed family member, if you have pension income, these sorts of things give you a pretty good idea of what the average income for that household is going to be. Right? So you develop this model using variables in the survey data that you also have in the census. Right? So there's a subset of variables that are covered in both sources, and so when you have this model developed on the basis of the survey, you take that model and you apply it in the census. And when you do that, you end up with a predicted value of income or predicted value of consumption for every household in the country. And in this case, you no longer have any problem with sampling error because you have an observation for every household in the country. And the only thing that you're worried about at that point is the modeling error, so how precise your model is. So the more precise your model is, the more accurate your estimate is going to be. So this, as I said, is sort of the gold standard approach, but it has some drawbacks. There are some difficulties in actually applying this method. The most important one is that it requires a census, right? And working with census microdata. And for any of you in the room who have tried to do this, this is quite a daunting task, right? One, the data are just very large. It's very difficult to work with census microdata. Certainly, getting access to census microdata is a long process in almost any country. I mean, it's often very sensitive. You have to organize a particular agreement in terms of how you're going to access the data and work with it. And censuses only happen every decade usually. So you can only do this approach once every 10 years. So these sort of estimates can quickly become antiquated or obsolete if there's a big change especially. So while this sort of method can give us very accurate predictions, it has some drawbacks as well. So this, some of the strengths of an alternative method I'm going to talk about now, and the alternative method is the one that we're going to apply for Kyrgyz Republic and the rest of the countries in Central Asia. And it's called the Harriett approach. As far as I know, the first time that the Harriett approach was used was looking at labor force statistics at the level of the state in the United States. And so the idea here is again to borrow information from a source that has no sampling error, right? You want to find a source of information that is related to the outcome, that is related to the outcome of interest, say income or poverty or consumption, but has no sampling error at all. And so in this case, one source of that kind of information is satellite data. And so what we're going to do in the following slides, I'll describe this a little bit more in detail, but we're going to take satellite imagery, satellite data, and we're going to also take the household budget survey for the Kyrgyz Republic, and we're going to match this information at the rayon level and develop a model that will give us a predicted value of what average consumption or average income will be in each rayon. And then we'll use a synthesized indicator after that to get a more accurate picture of poverty or consumption or income using this statistical approach. So there's some drawbacks to this. One is that there are some places, for instance, where there's no sample. Right? So there's no observations in the random draw of households that are participating in the survey. And this commonly happens in most countries when we're talking about a level of detail that the survey was not designed to represent. And in this case, what we're going to use is entirely a model-based prediction for the value in that location. Right? So in every other case, we have sort of two values. One that comes directly from the survey. That's, say, the average poverty rate for rayon X is such and such that we've pulled directly from the survey. And then we have a model-based estimate that's a predicted value on the basis of satellite imagery. And we take an average of those two, weighting them by the precision of the estimate from the survey or from the satellite imagery. So if the satellite imagery model is very, very precise, then that indicator is going to get more weight. If the sample is relatively large from the survey and we have a relatively accurate value in that location, then that value is going to get more weight. But in every case, we take a synthetic measure combining these two different data sources for each rayon. Now, if we only have one value, if we only have the model-based prediction, then that one gets all of the weight. Right? So if there's a district or if there's a rayon that has no survey value, we just take the value from the model. Right? So I went through that kind of quickly. Maybe I can stop here for just a moment if there are questions about that, or if anybody is unclear. It's a little bit complicated, so if you want to ponder it for a little bit, we can come back to it as well in the discussion. But the idea basically here is that we find a source of information that has no sampling error, and we use that so that we can that the only problem that we need to solve is modeling error, right? And when we apply that, we then take a synthetic estimate across both what we observe in the survey and what the model would predict the value should be in each location. So the data that we're going to use, I've already discussed it. So we have the household budget survey for the Kyrgyz Republic. Now this is collected by the statistical agency, it's the official data source. But the measures that we're going to be presenting here are all going to be sort of internationally comparable PPP adjusted values. And then the next step that we're working on together with the statistical agency will be applying this for national values, so national poverty rates, national income concepts, and so on. But for this first approach, what we're doing a regional-wide estimation to sort of demonstrate the approach and get an idea of sort of the comparisons between different regions of Central Asia. So I think many of you are probably familiar with the household budget survey for the Kyrgyz Republic, so maybe we won't go into too much depth here, but if you have questions, we can certainly cover those. We're using data from 2016. And then satellite imagery is available for free online if you are interested in doing this type of analysis. There's several websites that you can use. We can send you maybe a link if you're interested. But the data can be downloaded at the level of interest. So for all of Central Asia, you can download these data. You can download them from any country in the world. And it includes information that we would expect to have a strong correlation with average income or average consumption. Or poverty rates, right? So some examples of this would be nightlights, for instance. So we know that urban areas tend to have much higher nightlights, much more luminosity, which is correlated with economic activity. We can also use vegetation indexes. So we would expect that mountains have very low vegetation indexes. We have, we would expect that valleys have higher vegetation indexes. Areas that are more fertile are more productive for agricultural purposes, and this might be related to poverty and income. We can also use elevation. We can use the degree of rockiness in an area, so whether it's flat or sort of broken terrain. There's many of these examples, and in fact, if you go and you go to the websites that are available online at the level of, say, the rayon or the district, there will be thousands of variables like this that you could potentially use to develop a model. And so rather than trying to develop a model by hand, like going through these thousands of different variables and thinking about what might be the best or most useful indicator to relate to a particular outcome that we're interested in, we develop a machine learning algorithm, a really simple one, called a stepwise selection criteria. And so what this does is it goes through the list of all of the variables that we have that are complete, that are available for every one of the rayons that we're interested in getting a value for. And algorithmically, we add a variable in from this list. And if it's statistically significantly correlated with the outcome of interest, it stays in the model. And if it isn't, then we reject it. It goes out. And this way, we can go through a list of, say, 1,000 variables and develop a sort of candidate model to predict the value of consumption or income or another outcome of interest at the level of the rayon. Now, you might get worried using a method like this if you don't put other constraints on this, right? So one important constraint is that you want to keep the variance low in this sort of model. If you don't have a restriction on the variance that's being built up in this model selection technique, you can get a problem called overfitting, where the variables keep getting added in, but they're chasing just very small changes in the values of the outcome. And so what this can do is it can add a lot of noise to your model instead of making it more clean. And so we use an automated technique that adds in some restrictions on sort of how much variance can be added to the model. This gets a little bit into the details of this, but if you're interested, again, we can talk a little bit more about that. And so what you end up with using a model like this, you can also, after the fact, kind of go in by hand and move things around if you think that certain variables don't make sense and you want to use instead luminosity instead of vegetation or something like this. You can do that by hand if you like. The goal basically though is to explain the variation in poverty rates or consumption at the regional level as best as you can. And the models that we use here are clustered around 0.7 R squared, adjusted R squared, with a number of variables around, say 15 to 18, depending on the model. So we're relatively confident that we're not sort of overfitting, because we don't have hundreds of variables in the regression. And the sort of the share of variance that we haven't explained in the model is pretty low. Now we could probably do better than that if we added more information into the model, into the selection technique. So one thing that is quite promising is to work with statistical agencies, for instance, to use administrative data at the local rayon level. Right? So if you know, for instance, how many people in each rayon receive social protection benefits, you would expect that to be strongly correlated with average income or say poverty rates. Or you could also look at the number of schools or the number of people who have applied for some particular benefit, or the number of pensioners. These sort of pieces of information could considerably improve on the accuracy of that model, and is one of the reasons that this is just preliminary, because we hope that we're going to be able to improve on it by working together with partners. So let's see what the data look like for the regional level. So this is all of Central Asia before we do anything, right? So this is the data for all of Central Asia before we've touched anything in terms of the small area estimation, right? And we can see that there's sort of blocks of regions where the poverty rates are a bit higher or a bit lower. Here we're using the upper middle income country line at $5.5 per person per day in international PPP terms, right? So this is deflated to 2011 and then applying the PPP conversion factor, which makes these values comparable across countries in terms of their purchasing power. So this is what it looks like before we do anything. And then when we've applied this sort of statistical technique, we've sort of gone through this synthesis of the predicted value and the observed value, we get something like this. And you can see pretty clearly, I think, the motivation for doing this, right? You can already see that when you've disaggregated, there's clusters or there's areas where the poverty rates are higher within regions, and within oblasts as well, areas where the poverty rate is much lower. So we already have a much more detailed understanding of where some of the clusters of need might be. And this, of course, is very useful in policy making and discussions about how to allocate resources, sort of lagging and leading regions, and so on. So we've already sort of taken a step much further than we would be able to do if we were just working at the level of the oblast. And importantly, we didn't run into this problem that we were talking about before of higher costs, right? So all of this analysis is just a question of time, right? The data from satellite imagery is free. The data from the surveys we already have, the statistical agency already has it. So this is a way of getting more out of the data without increasing your costs by increasing the number of people and the number of in your sample and the number of enumerators and so on. So we've gotten something for a relatively good return, one could argue. So you can do this, so for poverty, for reasons that we can talk about, it's actually a bit more difficult to do this sort of approach than for other indicators. So poverty is, when we're able to do it well, it's quite a success, because it's a challenging indicator to estimate well, especially when it's quite close to zero, right? So when poverty rates are close to zero, say for the extreme poverty rate at $1.9 per person per day, in Central Asia, that's relatively rare actually. And so trying to get a model that would give you a very accurate estimate of this is quite difficult. And we have something similar to this even with 5.5 per day. There's many places in the region that have quite low poverty rates by that measure. However, something that's continuous, that's very rarely or never zero, like consumption, works much better. So why would it be very rarely zero? Well, if you don't have any consumption, you're not alive, I guess, right? So if you have a variable like this, you never run into the zero lower bound problem, and so your models perform much better. So here, this is consumption. This is average consumption in 2011 PPP terms by region. Again, before we do anything, this is just comparable data across all of Central Asia, and then when we disaggregate it, we can see pockets of areas where there's higher average consumption and lower average consumption, right? And this again is something that gives us a much clearer idea of pockets or areas where we might want to focus particular policy interventions on. So, and another advantage of this, you know, when I was describing this method, I noted that there's, you know, this machine learning technique that we apply. Well, every time we do a different model, or every time we do a different outcome, the model is going to be completely different, right? So when we're trying to predict the poverty rate, it's going to be a completely different set of variables from the model that ends up coming out when we try to do it for consumption. But if everything is working correctly, these things should be tightly correlated, right? We wouldn't expect there to be a poverty rate that's very, very high with a consumption rate that's also very high, right? There should be a negative correlation between these two things. And this is one way that we can validate the results. We should get consistent estimates across the different methods that we use. So I'm going to talk about that in just a moment. Of course, you know, for the people in this room and for most of the discussions that we're having during this mission, we're talking about the Kyrgyz Republic. We're not talking about Central Asia overall. Now, using Central Asia overall helps us a lot because we have many more observations to work with when we're developing the model, right? So we can, if we estimate it for all of Central Asia, the model can be much more precise, and then we can focus on the results in a particular country. So here in the Kyrgyz Republic, we have you know, areas where the poverty rate is higher, where the poverty rate is a bit lower, and these are the results for the $3.2 per person per day line, which is what we normally would use in the World Bank when we're talking about a lower middle income country. So take a look at this map. Another way of thinking about these results, or of presenting them, would be to look at what are the areas that are above average poverty and which ones are the ones that have below average poverty. So if you're going to split your resources, or you're thinking into those that are doing worse than average and those that are doing better than average, you can do it this way. You can visualize it this way, and it gets darker as the poverty rate gets higher, and darker red and darker blue when it gets further away from the average in the positive direction. So this is one way of visualizing that. One point that is also very useful. I didn't make these maps for this presentation, unfortunately, but so this is the poverty rate. So it's the share of people living in a location that are poor. But we know that population is very different depending on which region we're talking about here, or which district we're talking about here, right? So what you might be more interested in than the rate of poverty would be the number of poor people. And you can obtain this very easily just by multiplying the rate by the population total. So if there's, say, 2 million people living in a certain part of the country, you multiply the poverty rate by 2 million, and you get the number of poor people out of that, right? So we didn't do this for this analysis, but it's a relatively straightforward expansion of these results. So here we have the 5.5 per person per day. And as I was saying before, we would expect that when we are comparing values across different locations and across different models, they should hang together, right? They should be consistency across the different methods and the results across different locations using different models, right? So if we look, for instance, this district comes out as being quite poor in each one, as does this one. This one comes out as being quite poor, at least in 5.5 per person per day. So if we then look instead at, so this is again looking at below and above average values, a different way of visualizing it. But if we then look at average consumption, which has a different model entirely, we can see that, that this has a strong relationship, right? So lighter values here mean that the average consumption is expected to be lower here, here, and here, right? So this is one way that we might be a little bit less concerned that the model is giving us junk, right? Because it's telling us a consistent story across all of these different approaches. Does that make sense? Yeah? Okay, so this is, again, splitting it up. So this works for a lot of different types of variables, right? So we don't need to do this just for poverty and consumption. We work in the World Bank, so this is something we talk about all the time. But there's lots of other indicators of interest that one could be interested in, could use this method to get more accurate estimates, right? And here we have the share of households that have at least one household member who is a migrant for all of Central Asia, right? And if you cross this with the poverty rates or with the average consumption rates, you can see that this is very strongly correlated with the poverty rate and with low consumption values, right? Indicating already that there's likely a relationship between the poverty rate and people who are leaving to go abroad primarily for work. We can zoom in, of course, to the Kyrgyz Republic in the same way as we did before. And this is just a taste. This is just a single example of this. But you could do this in many other applications, depending, if you're interested in the labor force monitoring, if you're interested in, in health outcomes or indicators, if you're interested in consumption. There's many different applications along these lines that one could use a similar method for. And I should mention as well that the results that you get from this approach are going to be entirely consistent with the survey that you used to develop it, right? So we started with the household budget survey. One advantage of this approach is that we're going to get estimates that are entirely consistent when we aggregate them up to the regional level, at the oblast level. They're going to be entirely consistent with what we have observed in the survey, because that's where the information comes from, right? The only information that we have when we start is from the household budget survey, and so everything is going to be consistent with that. So that's...
Can I ask a question?
Please.
How come the migration coloring is different from everything else?
In terms of whether it's red or blue or what?
Well,
so,
it's not a question of coloring. It's that the migration, if they come from poor areas, right?
Yeah.
That doesn't seem to reflect on this one.
This is not, so they're not, it's not a one-to-one overlap where people are coming. Yeah, exactly.
There's
So
actually a significant difference.
So there is a very significant difference between them, right? So it's true that there are other things that are driving this, right? So we have a paper that we're working on particularly for Uzbekistan, which shows that one of the key drivers is the local labor market. So this is not necessarily a one-to-one mapping with average consumption levels, or in other cases it has a lot to do with a person's linguistic ability. So if they speak Russian very well, it's more easy to work in Russia, for instance, right? So there are other determining factors that are also playing a role with this. But the correspondence between the average consumption rate and the migration rate is very strong. So I can maybe follow up with more details on that if you're interested. But so there's like a linear relationship if you just do it by quintile. So the quintile of highest migration to the quintile that sends the most, that has the lowest average consumption overlap, and it goes on down the line. So I can share with you some more details if you're interested. So, but it's a good point that it's not a one-to-one sort of exactly those places that have high poverty rates are exactly those places that send more migrants. That's certainly true. Were there other questions? So there's a bunch more slides that get into some of the technical issues of how we validate these, of how we make sure that we're not just sort of making up numbers, and we can get into that. But if there's any questions about the maps or about the method, we can maybe talk about them now.
So you took data from the rest of the
No, it's mine.
Oh, just
Just here, what here.
Yeah, so this, so the data for the Kyrgyz Republic are coming from, so here, we can maybe go through each one. So the data from the Kyrgyz Republic are coming from 2016. The data from Kazakhstan are coming from 2017. The data for Tajikistan are 2015, and the data from Uzbekistan are 2018.
Okay, thank you very much, William. Information. Well, I myself have plenty of questions, but probably maybe people have asked questions. Yes, please.
Thank you for a good presentation. My name is Seitz. I work at French Institute for Social Asian Studies. And I think it was really a lot, dense, a lot of information. So thanks a lot. My question is that, first of all, you mentioned that this imagery, and you can actually, work on the model online, right? It's possible to find this online. Okay? So the first question is, did you get this online? Is it publicly accessible information, first of all? Secondly, when you use these models, you mentioned there's a confidence level. I'm not an expert in statistics, but when actually these models are used, given that you take the entire population data, basically you can say that there's no margin of error, right? You just say it's a model taken from the entire population because you're using the census data.
So these are both great questions. Thank you very much. So on the access to the data, so the survey data come from a couple of different sources, but they're all survey data that are. So in Tajikistan, in the Kyrgyz Republic, and in Kazakhstan, they're all surveys that are conducted by the statistical agencies. So access to those is governed by the rules that the statistical agencies have for sharing data. In Uzbekistan, it's coming from a study that the World Bank has conducted together with local partners called Listening to the Citizens of Uzbekistan. So these data are available to partners in Uzbekistan, but will be available publicly within a year. So that's for the survey data. The satellite data are all publicly available right now. So you can go online and download this information whenever you like. So an easy way of doing it is to go to the College of William and Mary's website. They have it's called aiddata.org. They have sort of a harmonized data set that allows you to download a lot of this information very easily. So that's one way of doing it. You can go to Google, the Google Earth API allows you to download a lot of this information as well. OpenStreetMap has a lot of information that you can use for this.
For the actual platform to have this imagery.
So all of the analysis and the mapping is done using a statistical program called Stata. Stata, if you've ever used that. It's not a requirement to do the analysis in Stata. The two main ones that you can use to do similar analysis to these are a program called R. It's an open statistical programming language. And Stata, which is proprietary, but you can get sort of older versions of the program relatively easily. And in both, there are modules that you can download for free once you have the software that would allow you to do this. So in R, it's called SAE. I'm trying to remember the. If you just search SAE in R, you can get that package very easily. And then in Stata, the package that we use here is FHSAE. So to your second question, the second question on the margin of error. So So in this case, we're using the survey data still for the estimates, so there's going to be a margin of error from the sampling design that comes from the survey, right? What we've done is we've made the standard error smaller because we've become more precise in our estimates, borrowing from precision from satellite imagery, right? So whenever we're doing this sort of approach, there's going to be two sources of error that we're worried about. One is going to be the sampling error, which we've discussed before, and the other is going to be modeling error. So the variance that we can't explain using the statistical model, right? And that then gets replicated when we do a prediction of the value of the.
So you have two marginal errors.
So there's two sources of error, and you can combine those two and create a confidence interval around each point estimate. And so there's a very large sort of question that many people often would be worried about is sort of what is sufficiently precise data to present to the public, right? And in many countries they have specific guidelines for what's an appropriate number. But if you were to take a look at it from a sort of a statistician's point of view, it depends on what the use of the statistic is. So what you're using it for is the most important criteria that will tell you sort of how precise the estimate needs to be. So one way to evaluate how well we've done is to look at other poverty maps that use the gold standard approach, right? So this gold standard approach that I was talking about before uses census data and not satellite data, right? So in the place of the satellite data that we've used, they use census data, and that gets that you would expect would get you a more precise estimate. And so here you can see this red line is the point estimate, so it's the expected poverty rate for each location. And then on the top, we have these blue dots, which are the upper bound confidence interval for, I think, 12 or 13 poverty maps that were done using the sort of gold standard approach, right? So we've just rank ordered for each location in each poverty map the poverty rate, and then look at the top of the confidence interval and the bottom of the confidence interval, which are these gold points here. And then overlaid on top of that, we have our upper and lower bound confidence intervals for the map that we've just done for all of Central Asia, right? So this is for a 5.5 poverty rate. And we can see here that these green ones are often overlapping with where the gold standard ones are, right? So in the case where the people felt comfortable in publishing the gold standard poverty rates, or the gold standard approach using ELL, is about as good as we do here in this case. The exceptions are these ones, where you see that they fall outside of the 95% confidence interval for the gold standard ones. So you can see these green ones here and these darker blue ones up here. And the reason for that is these are the cases when we have no direct estimate, right? So when we have no survey sample in any of those locations, we entirely rely on the model to give us a predicted value, and this tends to be less precise, right? So this is one of the main advantages of using the ELL approach, is that you never have a location, you never have a district or an ion that doesn't have any sample in it. And so you would never have these cases that fall outside of the confidence interval. So this question, though, about what's the appropriate threshold, or how precise do we need to be before we start publishing these numbers, is for poverty rates, it's a difficult question. There's a lot of different views on that. For continuous variables that are far away from zero, the most common way to do it is to use what's called the coefficient of variation. So the coefficient of variation is, for those of you who remember from your statistics classes, it's the standard deviation of the measure divided by the average of that measure, right? So say we have average income, right? We calculate a standard deviation, and we divide the standard deviation by the average, and that will give us a ratio, right? And many statistical agencies or practitioners will use a ratio like this as their cutoff. So if it is above a certain threshold, nothing can be published. And so a common one is to use say 10%. So that's one that's used in some countries. There's more aggressive ones that would use something like 8 or even 5%, right? And so what we can see in these these gray cases are the coefficients of variation for average consumption for the sort of unchanged data. Sometimes fall above those thresholds, and we wouldn't be able to report those in a standard statistical report. Now, after we've done the Harriett improving the precision sort of process, we reduce these by some amount, and in particular we reduce them in the cases where the coefficients of variation were the highest. And this is the reason, this is the main advantage of this approach, right? So if we look, I have another slide here. So these are standard errors, right? So just this can be converted into a confidence interval that'll tell us sort of the upper and lower bound of that measure. And we can see where the standard error from the direct estimate, this gray line, was very low. So we had a very precise estimate already, meaning that we had a lot of observations in that place already. The model doesn't do much for us, right? The direct estimate was already very precise, and so adding more information doesn't really help us very much. But when we move up this distribution, when the standard errors get larger, that's when the model really kicks in. That's when the model really starts improving on the standard error. And so it's at these places where we're most concerned that we have an imprecise estimate that the Harriett model does the most to reduce the imprecision.
Well, people are thinking, let me ask my questions. So first of all, do I understand correctly that this is mostly for rural areas, and for urban areas this methodology is not needed and may not work? Well, mainly is not needed because, well, Bishkek, for example, we have a substantially large sample size already, so you can measure directly without any additional imputations. Secondly, may not work because, well, you are averaging on a small geographical area for many people and high inequality in urban area also, which may be also all omitted. Is it correct?
So yes and no. I agree that if depending on how the sample was designed, you may have a large sample within an urban area, especially if that was one of the design strata of the survey. So in Bishkek, I think that is the case. It's a design strata. So you for sure have a large sample in this one location, which means that you don't need to do anything special. What's going to happen in this case is that your estimate is going to be very far on this part of the distribution, so the model is just not going to do much for you. But there's no need to do anything special, right? It'll just ignore the model for the most part and give most of the weight to the direct estimate. Now, it could be the case though, if somebody was using just a normal distribution sample, right? So if somebody was not doing a stratification, but just doing a simple random sample across the country, that you have a relatively small number of people in a city, right? So just to take an example. In this case, the model could help you, even if you don't have a very large sample, because there could be variables that are not just about sort of the space of the place, but the characteristics of the place in comparison to others, right? So one good example of this in satellite imagery is that almost always the luminosity of the location is a very strong predictor of the value of the poverty rate or the average consumption rate.
Yeah, but take this further. You can have one household, very rich, spending a lot of energy, producing a lot of light, and next door, very poor household.
Yeah.
You can't distinguish them, right? So you average, and then you count this poor household as doing pretty well, because you also average it from very rich neighbor. Is it kind of possible source of error?
So this is correct, right? So what we're achieving, or what the objective here in the estimation strategy is to get an area level estimate of the average poverty rate, and not the individual household level poverty rate. So so if we were developing a model, and the purpose of that model was to determine for an individual household if they are poor or not poor, this would do very poorly, right? This would tell us that we would give everybody in a region the same probability of being poor, right? But we know, especially in a place with a lot of inequality, that's going to be a very rough way of trying to do this. But if our objective is to say what regions or what districts are, on average, do people need more support, say for our budget allocation, right? when we're thinking about how much money we should put into social protection for each district, we're not interested in the specific household in a district that's poor. We're trying to think of what overall is the correct allocation when we're comparing districts, right? And so that's what this model would be helpful for, or that's what this sort of approach would be helpful for.
We'll continue this further again. Well, imagine a district where 50% are rich and 50% are very poor.
Yeah.
And using satellite imagery, you may conclude that, because you average them, you may conclude that this kind of middle-level district with no serious poverty, while there is a lot of poverty, mixed with a lot of welfare. Possible?
So it's possible to have. So if we think about so if we get a poverty rate like this, right? The poverty rate is going to be sort of agnostic about the inequality in the place, right?
Right.
So we get a poverty rate for a place, for a particular district, and it's knowing the number of poor people that are expected to live in that district is a simple sort of mechanical product of the number of people living in that district and the rate, right? So in that case, we would have, a huge number of people who are poor, and then a huge number of people who aren't even close to the poverty line, right? So if we were trying to do instead a measure of relative poverty, right? If we were trying to do, or a measure of say just straight inequality like the Gini coefficient, this model might not be a very good approach to that. And in particular because it's not going to be very sensitive to the extremes of the distribution, right? As I was saying before, when you're trying to do a poverty estimate for a place that has a very low poverty rate, right? So say you have a poverty rate in a location of say 2% or 1%, the variation that you're observing in the modeling process is so small that you just have very little to work with when you're trying to do this approach. And the same would hold true when we're trying to do it for inequality. Right? So if the question is how many poor people do we think live in this place, it's agnostic to the rate of the inequality indicator, and we're just going to get a number of people, and then there's a different sort of set of questions that we need to ask ourselves in terms of how to identify them once we go there, right? But if the question is different, if the question is on inequality, then this might not be a great approach to estimating that.
There are a couple of hands, but let me ask my other second, last question. So far, can you please return to the one of the maps on this poverty, the regional ones?
The regional poverty.
Yeah.
So for
no. Well, we have several countries. Yeah, well, for example, even consumption.
Okay.
So, well, I may be wrong. It looks, however, that Kyrgyzstan is generally more poor than Tajikistan, according to these maps.
Yeah.
And we know from many sources, from macro statistics, from different sources, that's the other way around.
So I don't know if that's true. I would say that it has been for some time that Kyrgyz Republic was traditionally sort of ranked, if you were to compare it to Tajikistan, as having higher average consumption or higher average income. But this is going to be very sensitive when we start converting this into international PPP, right? And so in the last PPP estimation round, I think that they actually switched places.
I just recently looked at these numbers like yesterday. I don't remember the PPP, but I believe we have roughly the same ratio of PPP rate to market exchange rate. So Kyrgyzstan has 50% more than Tajikistan. It's not a small amount of difference. We have 1,200 according to the current exchange rate, and Tajikistan has 800. And, well, of course, there are some poor areas in Kyrgyzstan, and there are some well-doing areas in Tajikistan doing well. But this too much difference on average to...
Yeah, it's an interesting question. I mean, we can look into this even in more detail. But so I know, for instance, at the World Bank right now, for the poverty rate that at 3.2 for lower income countries like Tajikistan and Kyrgyz Republic, puts the poverty rate for Tajikistan lower than for the Kyrgyz Republic.
That's because well, if you look at also some non-monetary indicators like stunting rate, in Kyrgyzstan it is much lower than in Tajikistan. That's different alternative way of measurements, different samples, but so well. Just please double check.
Yeah, no, I take the point. You know, and another thing that's I think important about this question that we might want to also discuss at some point and look into more deeply is that you know, there are differences as well in the way that the data are collected in different places, which might have an impact on the amount of consumption that one estimates, right? So in particular, these two surveys, right? So the survey for the Kyrgyz Republic and for Tajikistan. In the Kyrgyz Republic, this is a diary that's being collected, right? And in Tajikistan, it's a recall-based method. And so the diary method is traditionally viewed as being the sort of gold standard approach. And the reason for that is that you know, there are a lot of items that might not be included in a list if you ask a list of consumption items, and they might be left off of the list. And if that happens, then you're going to get lower consumption by construction, just by how you've asked the question, right? You would never run into this problem using a diary. On the other hand, diaries are very, very susceptible to poor implementation, right? Or put differently, it's very easy to not collect all of the consumption that a household has using a diary. And this is a pretty intuitive problem. So if we were to think, for instance, about a situation in which we are, so say you're a respondent, right? And somebody comes to your house and they give you a big book and they say, I want you to every day write down everything that you've bought for food for a whole month, right? What I think I might do, and I think what many people might do, is say, sure, I'll do that, and then I wouldn't do it, right? I would forget, or I would do it maybe once a week, or I might not do it entirely. And then when the person comes to pick up my book, I would quickly write in whatever I thought that I had consumed over the last month, right? This happens a lot. So there's a lot of research on this that shows that the implementation of these is pretty variable. And so in a case like this, what you're actually getting is a month recall, right? What you're actually getting is somebody trying to remember for the last month everything that they consumed. And this tends to be this tends to undercount things that people are actually consuming. Right? And so one potential problem that we would maybe want to try to take into account for these sorts of estimates, which you know, for many international comparisons are not taken into account at all, is just the differences in the instruments that are being used to collect the data. Right? So if you look, there's there's Kazakhstan, which is using a diary. There's Kyrgyz Republic, which is using a diary. There's Tajikistan, which in this case, which normally is using a diary, but in this case is using a recall approach. And there's Uzbekistan, which is using a recall approach, right? And so this is just one sort of difference that might play a role in that as well.
Okay. So I'm also from the IPPA research fellow. Actually, in the past, I was very often involved in the spatial analysis based on satellite data. And I would give you just example. I don't want to argue or try to correct whatever you do, but you know that the poverty you measure based on the food basket, mainly, it's based on survey. And then the poverty you try to measure through the satellite analysis based on the access to services or whatever kind of different type assumption. How are you going to put it together? Because it's easy when you take this $5.5 a day based on survey, but what is your so-called milestone or unit you use for the satellite modeling? What is this?
That's great. Thank you so much for this question. So the idea behind this is that we use the survey data directly, right? So we never run into this problem that you're raising. So what we have, what we start with, is a poverty estimate. Say we calculate directly in the survey the poverty rate at $5.5 a day, and then we match that rate for each district or for each rayon with the satellite imagery for that rayon, right? And then we develop a statistical model across all of those observations, right? So we're always benchmarking directly to the $5.5 a day measure directly from the survey, right? And so it's always going to be exactly what we get from the survey when we average it to the level of the unit of representation in the survey, right? So that's basically the idea, that we're not trying to predict anything from the satellite imagery that we observe in the satellite imagery. What we're trying to see is what's the relationship between the survey data and the satellite imagery that can improve on the survey precision, right? Not changing the estimates, but improving on the precision.
Okay, then another.
Sure.
I was also involved in a lot of rural surveys, and I'm familiar with the habits people have in rural areas. So there were guys in Austria, they also wanted to use electricity and the lighting system in the night, and that was a failure because in the Central Asian countries, in the rural areas, they used already have a saving habit to switch, do not use electricity or try to go sleep before it's dark. And another issue was that there is no access available. In some part of the village, there is no electricity supplied. So potentially it doesn't matter how rich or poor you are, you don't have this electricity. So, and what we did then, we tried to clean up this kind of modeling. I don't know, you said that you're using the machine learning, but I would say that be accurate when you are using this. Right now I see that you're kind of checking up. So this is not about trying to put it together, this different knowledge. You're just checking up some findings through the survey by looking at the spatial data, which is really good. But because you're still inside the district, which is quite large here, and then again, it depends on how you're going to cut it into pieces. And usually we do this like kilometer by kilometer, and then you make a...
So in this case, that's not what we're doing. So in this case, we're just averaging it across the district, and we're matching it with the poverty rate at the district, right? So we take maybe the max luminosity for the district, the mean luminosity for the district, and the minimum luminosity for the district, and we just see whether there's a statistically significant relationship between that and the poverty rate, right? And that's sort of all we're checking. Right, that there is this sort of relationship.
Except of this elimination, can you briefly give me at least 3 or 4 components of this spatial analysis? Like, I don't know, the quality of roads, or just said about the quality of the soil, which is, I think, or the vegetation, which is kind of questioned in terms of Central Asia. We have a problem of vegetation everywhere. I don't know how it would be different. I would say that.
So like in this case, we're not sort of saying that, so we're not necessarily imposing anything in particular on the interpretation of the relationship between those two things. All that we're showing is, in this case, like the only variables that we're going to include up to a certain number are those that actually correlate strongly with the thing that we're looking at, right? And we're not saying that this is causing one thing or the other. All we're doing is saying we're trying to get a prediction, right? And we're looking for any variables that do a good job of giving a prediction. One of those is almost always luminosity. Right. So this idea about the lighting is like, it almost always very strongly correlates with average consumption and poverty rates. Vegetation, again, like almost always very strongly correlates with average income, right? So we're not necessarily saying anything about the interpretation of the relationship between those two things. We're not saying that, this certain level says that there's that this is causing a certain level of income among the people. All that it's saying is that in the data we observe, a strong correlation between these two things, which helps us get a predicted value. That's all we need, right? And if we were to find that there's some really weird indicator that that you would think has no relationship whatsoever with consumption, or no relationship whatsoever with poverty, that comes out as being really predictive, there's no reason that we have to include it. We don't have to include anything that we're sort of questioning in terms of maybe it's mismeasured or it's some spurious correlation, right? And we can drop it. There's no rule about this. The point is not to develop a model that tells us about what is causing poverty in a particular place or causing income. All that we're trying to do is explain the variation so that we can get more precise estimates, right? To reduce the standard errors. So, sorry, please, yeah.
Thank you. Can I ask about migration? Because it was not the focus of your presentation, right? But I was wondering, since Bogdan mentioned that the migration and poverty or consumption do not really match one-to-one, I was wondering whether you kind of explored other significant explanations, but they're not matching. You mentioned language, Russian language. What would be the other?
No, so I think that would be the wrong interpretation of that result. So the result basically shows a very strong correlation between migration and level of consumption, right? So if you just take the value of consumption and the value of and the average rate of migration from a district, there's a very strong relationship with that. But it's not a deterministic one, right? All that we're saying is that it's not that there's like a one-to-one mapping of the two things, right? There are other things that also matter for migration.
Yeah,
but there's a very strong relationship between them.
But you didn't look at what would be the alternative, like environmental degradation. Does it matter or not next to poverty?
So I would use a different approach to measure this, which we've done much more in places where we have sort of individual level data where we're looking at people moving out and what's driving that decision. So we've done much more of this in Tajikistan and in Uzbekistan. So we have two surveys that are looking at this issue in particular. One's called Listening to Tajikistan, and the other I mentioned before, Listening to the Citizens of Uzbekistan. And these surveys are panels, so they have, every month we talk with the same households. And in those, because there's such a high rate of migration from these places, we see a relatively large number of people leaving. And because it's a panel, we can look at an individual or a household level fixed effect and say, what characteristics sort of predict a household member leaving this particular location. And what we find in both places is that it's very commonly related to the labor market, the local labor market. So what we find in the case of Uzbekistan is that the unemployment rate locally is highly predictive of leaving. Losing one's job is highly predictive of leaving. Having the district or the mahalla in that case having a high reliance on social protection is highly predictive of leaving. So these, at the individual level, when somebody is very pessimistic about their ability to find a job or very pessimistic about the local economic conditions, they're much more likely to leave. And then we can look at what happens when that occurs, when people go abroad. So what I would say is that all of those things would be correlated with poverty rates, right? So we would expect there to be a strong relationship between the overall poverty rate and the migration rate, but the individual determining factors of who's migrating and why are not going to be exactly the same as the overall poverty rate for a district. Yeah.
What are the dates for these maps for migration? Because it's not mentioned here.
It's the same as the others. So it's 2016 in Kyrgyz Republic. In Uzbekistan, this is all from 2018. In Kazakhstan, it's 2017, and in Tajikistan, it's 2015.
Any more questions? Еще вопросы, пожалуйста.
Thank you much for this presentation. My interest is about the relationship with this country's statistical committee.
Yeah.
According to the results of your surveys, all these indicators should be implemented in some way in practical way. What's the level of relationship with government of these centralizing countries?
Thank you very much for this question. So in every case, the idea for this is a starting point for discussion for improving on this using additional information. So if we have more information from administrative records, we can do much better than this. And also, as we know, in a country context, this sort of international PPP converted measures are not very useful, right? Because that's not what countries actually use for policymaking in most cases, right? So in the case of the Kyrgyz Republic, the national poverty rate is what's used for most policymaking, and this international measure that the World Bank uses is kind of, it's interesting for benchmarking purposes, for comparing one country to another country, but otherwise it's not what's being used for policymaking. And so, as part of this work, we're going to each of the countries, sort of describing the results and sort of agreeing to next steps in terms of having country-specific estimates that are useful for local policymaking purposes. So thus far, we've sort of agreed with the statistical agencies and the ministries of economy and the ministries of labor and social protection in Uzbekistan, in Tajikistan, and now yesterday in the Kyrgyz Republic, that we would be doing these together and having a joint report on the results, right? So this is just sort of the starting point to sort of demonstrate the method, and then in the next step we do a much better job with more data, with better, and more targeted towards the needs of each country, because this map is useful for like seminars, it's not very useful for policymaking. And when we actually get down to brass tacks, right? So the only country left then is Kazakhstan, so we're going to be presenting this with them very soon, and we've already done some work jointly with them using a similar method up till 2015. So we expect that this would be just a continuation of something like that.
Еще, пожалуйста. Пока люди думают, и у нас еще есть немножко времени. Если можно, я еще один вопрос. Also, one more question. Well, actually, Marina started asking that. Do you have, well, images is fine. Do you also supplement it with some kind of other information? For example, there could be some, especially you go now pretty small level, the small area, some pockets. Do you have special variables which would allow accounting for those pockets? For example, some peculiar ethnic mix, some peculiar language situation, environmental issues, whatever. Do you have this information? Or you methodology how to insert that and to predict poverty in those pockets differently than general system predicts?
Yeah, that's a really interesting point. So, I mean, one thing that we can try with this sort of thing that we do here as much as possible is that we have regional groupings. So for instance, if you have a region fixed effect in a regression model, that whatever is particular about that region in the modeling would go into that fixed effect, right? And so here, what we can do is we can have country fixed effects, but we can also have sort of cross-regional fixed effects, right? So we can say maybe like the districts around here are special for some reason. They have similarities for some reason. We can have just a dummy variable, an indicator variable, that would group them together, saying that there's something special about them, and then anything that would be special about them at a spatial level would go into that fixed effect, right? So that's one way you could do this. Another way would be to just say, so if there's an ethnic minority that has above and beyond all these other explanatory variables a lot of predictive power in average income or consumption. We could include that as long as we have that information for every district. So if every district has 0 and then 4 of them have 20% or something like this, if you put that in, it's 0 for most places, and then for these particular locations, that would have a transformative impact on the predicted value for that location. You could certainly do that. The only constraint on these sorts of additional sort of indicators would be that we have that information for all of the districts in the same way. So that's the only constraint. Yeah.
But what you mentioned earlier is that you start playing with dummies. I understood it is machine learning, so it's done automatically. But then you can also do it by hand for some adjustments.
Yeah, absolutely. Yeah. So if you get something that seems very weird and you have no idea why it comes out this way, so if you have some strange combination of variables that give you a very weird relationship, you don't have to use these, right? You can pull them out. And in my experience, it hasn't been these very exotic variables that tend to do a lot of the work. So almost always it's something very simple, like what's the average luminosity for this place? That gives a very strong predicted value of the average consumption. Or if you look at, there are other, so the UN has district level estimates of population, right? So you put that into a regression, it's going to give you a pretty good predictive value of some outcomes if that's what you're trying to predict, right? It's a very good correlate for many things. So these sorts of very intuitive relationships are the ones that almost entirely drive the predicted value. It's only in very rare cases where you get some strange, something to the cubed root, value that like has some very strange relationship.
Come to poverty level for Kyrgyzstan, for example.
Yeah.
Because I have very particular part in mind.
Yeah.
Yeah, or one of the zones. Or for example, you have a lot of poverty here. And this is, as far as I understand, is Census area. This is area known for a lot of cattle. So I think on poverty measurements, they will not be poor. But maybe infrastructure is not very good here. So in terms of luminosity, they may be behind, they have more poor neighbors.
Yeah.
This area which is considered, well, this requires local knowledge, and I don't pretend I really have this local knowledge.
Yeah.
However, I believe if you start discussing in each and every region separately, there will be many questions of that kind. I'm surprised this has very low poverty and this has much more poverty. Because the closer to Bishkek, the richer regions are in general. But that's, well, so you see.
Yeah. So one thing I would point out with questions like this, which I think are really important things, is that so if all of this was based on an estimate from satellite imagery, right? We didn't have anything else. We were just like we had a model and we got a predicted value and we put that on a map. I would be worried about that, right? I would be very worried that we're going to get some sort of strange relationship that gives us a very poor prediction in a particular area. But what we're measuring here is what the survey says, right? So we put what the survey says on a map, and we're just adjusting that at the margin, right? We're adjusting that only insofar as the satellite.
You make model based on country, not on the region, right? The model is countrywide, right? So it puts weights which are important for different parts of the country.
So there's a weight for each district. There's a specific weight for each district, right? So for each district, I forget the name that you said for this one right here. So we have the survey-based estimate for this, right? So there's some number of people who are actually interviewed here, and we get a poverty estimate that we know isn't very precise, but it gives us an idea of roughly what it should be, right? And then we have this other model that is a statistical model based on these other things that gives us a predicted value for this one, right? And so all that we're doing is we're adjusting at the margin this the value that we get here to make it a bit more precise. We're not giving a totally new value from what the survey says, right? So by construction, whatever the survey said the poverty rate is for this area will be the same that we have here. Right? We're never going to get a poverty rate for a region that is going to be totally different from what the survey says. Basically what we're trying to do is we have a poverty rate at the oblast level, and we're trying to allocate that poverty to the constituent groups within that area using the statistical model. That's kind of what
I
happened.
wouldn't pay too much attention, and you know about, we have many statistical reasons don't pay much attention. There are 20 households in this district. Why should we care much about the average position? If we have just 20 households in this district, the average for these 20 households may not tell us much, right?
In which case the model would be given more weight, right? And we would have a standard error around this that would be relatively large, right? We would have a relatively imprecise estimate for this one. If we have a larger sample, then the model would do less, and we would have a relatively sharp and precise estimate.
William, it's a very good way of thinking, and I got a lot of ideas from your method and from your application. But for the future, some important knowledge about rural studies and the measuring of the poverty. The poverty is seasonal in the Central Asia.
Yeah.
So I would say in Kazakhstan it's really visual, so you can not do anything, you just go and see that winter time the people having this $5.5 are getting less than in the summertime. And this is related with mobility, the lack of access, a lot of issues around here. But when we look at the satellite data and try to check something, I know these data sources and I know the accuracy. And those are all taken mostly summertime. So just for the future research, consider that the poverty measurement right now with the climate change, with a lot of things we are experiencing now, should be seasonal, especially for the rural areas. They really, often when we measure their poverty, it's summertime, but it's not true. Go and measure it in intertime, and you will get it higher.
So I think this is an excellent point, and I would love to talk more about this because it's something that I think is an incredibly important issue here in Central Asia in particular. I think it's it's not a unique, but it's a very strong feature of poverty and well-being in Central Asia, these very strong seasonal fluctuations. I would say though that for this particular application, that's not going to be a bigger problem, right? And the reason for that is that the surveys that we're using here are continuous. So they're collected from each period of time. So every month there's more, there's some share of the data that are collected. So in the case of the Kyrgyz Republic, it's 5,000 households that are interviewed every quarter. So we're not focused only on one season, we're focused on the average across the whole year for each place, right?
I'm trying to disaggregate and look at this.
So I think that this would be very interesting, right? So if you try to do this, instead of looking at, say, 20,000 observations across the entire year, but if you try to do, say, the poverty rate seasonally, and then do maps for each of those and try to do this, if the measures are sufficiently precise, I think you would get a very interesting discussion about these fluctuations within seasons. And indeed, I have worked quite a bit on this in Tajikistan, where the fluctuations are even stronger. And there you see very strong fluctuations in poverty from one period to the next. And it's very important when you do the data collection and what time periods are being covered, right? So I totally agree with you. But for particularly the Kyrgyz Republic, these data are continuous. So the seasonality should be smoothed out because of the sample design.
Have you tried live in Kyrgyzstan data?
No. We don't use
That's seasonal. That's one way only.
So we have we are for the reasons that this gentleman raised earlier, we were using to the extent possible official data from the counterparts in government so that these can be more useful for actual policy making.
Okay, guys, well, thank you very much. I think it was exciting. Спасибо большое. Очень-очень интересно, да? Поблагодарим.
Thank you very much.
Когда у вас будут какие-то готовые письменные результаты, пожалуйста, дайте нам знать. Будем все читать очень внимательно. Спасибо.